Hello students, in our previous class we learned about geometric progression, then its terms, that means how we can find its nth term. Okay, then two terms related with geometric progression. In this class we will learn what do you mean by geometric mean, then the relationship between arithmetic mean and geometric mean, and lastly we will learn how we can find the summation of all the terms present in a GP. Okay, so let us study about geometric mean. Definition. Geometric mean or means of two numbers is or are that or those number or numbers which is or are along with the given two numbers will create a GP. Okay, so geometric mean or means of two numbers is or are that or those number or numbers which is or are along with the given numbers will create a GP. Okay, that means if C be the geometric mean, that is GM in short, of two numbers A and B, then by the definition of GP we can say that A, C, B are in GP. So if C be the geometric mean of two numbers A and B, then by the definition of geometric mean we can say, then by the definition of geometric mean or GM, we can say that A, C, B are in GP. That is, C by A equals to B by C. This implies C square equals to AB. This implies C equals to plus minus root over of AB. Okay. So if C represents the geometric mean of two numbers a and b, then by the definition of geometric mean we can say that a, c, b are in GP, and then from the definition of GP we can say c by a is equals to b by c, and from this we get c squared equals to ab, and then c equals to plus minus root over of ab. Okay, again if PQR are the geometric mean of two numbers a and b, then by the definition of geometric mean we can say that A, P, Q, R, B are in GP. That is P by A equals to Q by P equals to R by Q equals to B by R. Okay. So this is the concept about geometric mean or means. Okay. Here we choose a problem. In this problem, we have to find four geometric means between 7 by 4 and 56. Okay. Solution. So, four geometric means along with 7 by 4 and 56 will create a GP. That means 4 geometric means between 7 by 4 and 56 can be represented as 7 by 4 blank 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 56. That means we have these four blanks along with 7 by 4 and 56 will create a GP. So here first term A1 is 7 by 4 and sixth term A6 is 56. Okay. So these four blanks represents second term A2, third term A3, fourth term A4, fifth term A5. So to find the geometric means A2, A3, A4, A5, we have to know the first term A1 which is already known, and the common ratio of the GP. Okay. So here the four geometric means between 7 by 4 and 56 are A2, A3, A4, A5, which are along with 7 by 4 and 56 will create a GP from the definition of geometric means. So to find the geometric means A2, A3, A4, A5, we have to know the first term, which is already known, that is 7 by 4, and the common ratio of the GP, which is not known now, but we have to find the common ratio with the help of these given terms, that is 7 by 4 and 56. Let the common ratio of the GP be R. So therefore A6 equals to 56 imply A1 into R to the power of R to the power of 6 minus 1 equals to 56. Already we know how we can find the nth term of a GP. N equals to A1 into R to the power of n minus 1. By this formula we can write A6 is equals to A1 into R to the power of 6 minus 1. A1 is 7 by 4 into R to the power 5 equals to 56. This implies R to the power 5 equals to 56 into 4 by 7. Cancelling 7 and 56, we get 8. 7 8 is 56. So R to the power 5 equals to 8 means 2 cube and 4 means 2 square. So R to the power 5 is equals to 2 cube into 2 square will give 2 to the power 5. From the formula of exponent, when bases are equal, then in the time of multiplication we have to write common base and then sum of the powers. So 3 plus 2 will give 5. So this will give R equals to 2. Since A to the power m equals to B to the power m imply A equals to B. So now common ratio of this GP known to us, that is 2. So therefore A2 equals to A1 into R to the power of 2 minus 1 imply A2 equals to 7 by 4 into 2 to the power 1, that is 7 by 4 into 2, 2 2s are 4, that is 7 by 2. A3 equals to A1 into R to the power of 3 minus 1 imply A3 equals to A1. A1 means 7 by 4 into R means 2. So 3 minus 1 means 2. So 7 by 4 into 2 square. This will give 7 by 4 into 4. Cancelling 4. We get 7. A4. A1 into R to the power of 4 minus 1. This implies A4 equals to 7 by 4 into R means 2. So 2 cube. So 7 by 4 into 8. 4 2s are 8. So this will give A4 equals to 14. A5 equals to A1 into R to the power of 5 minus 1. This implies A5 equals to 7 by 4 into 2 to the power 4. This implies A5 equals to 7 by 4 into 2 to the power 4 means 16. 4 4s are 16. 28. So the four geometric means between 7 by 4 and 56 are 7 by 2, 7, 14 and 28. So this is the way by which we can find four geometric means between 7 by 4 and 56. Relationship between relationship between the arithmetic mean and geometric mean of two numbers. Now we will learn what is the relationship between the arithmetic mean and geometric mean of two numbers. Okay, already we know what do you mean by arithmetic mean or mean of two numbers, then geometric mean of two numbers. Now we will find the relationship between these two, that is arithmetic mean and geometric mean. The arithmetic mean here we consider two numbers be A and B. So the arithmetic mean of A and B is A plus B whole divided by 2. Already we know the arithmetic mean of two numbers A and B is A plus B whole divided by 2. So the arithmetic mean of A and B is A plus B whole divided by 2, and geometric mean of A and B is root over of AB, taking positive value. Okay. If C represents the geometric mean between A and B, then we have C squared equals to AB, and from that we get C equals to plus minus root over of AB. So here we choose the positive value of the geometric mean, that is root over of AB. So the arithmetic mean of AB is A plus B whole divided by 2, and geometric mean of AB is square root of AB. Now arithmetic mean minus geometric mean equals to, arithmetic mean means A plus B whole divided by 2 and geometric mean means square root of AB. Nothing is here means 1 is present in the denominator. The LCM of 2 and 1 is 2. So after subtracting we get A plus B minus 2 into root over of AB. we can write a as root over of a square, b as root over of b square, and minus 2 into root over of ab as 2 into root a into root b whole divided by 2. This is an identity. This is like x square plus y square minus 2xy equals to x minus y whole square. So, by following this identity, x square plus y square minus 2xy equals to x minus y whole square, we can write this as root a minus root b whole square by 2. Okay. If a equals to b, then root a is equals to root b, imply root a minus root b whole square by 2 equals to 0, imply arithmetic mean minus geometric mean equals to 0, imply arithmetic mean is equals to geometric mean. Again, if a not equals to b, then if a not equals to b, then root a minus root b whole square by 2 not equals to 0, imply arithmetic mean minus geometric mean not equals to 0, imply arithmetic mean is greater than geometric mean. Because if we subtract between two numbers, say x and y, then if the difference is not equals to 0 or greater than 0, then if when we find the difference of two numbers and if the difference is greater than 0, then we can say the first number is greater than the second number. That means if x minus y is greater than 0, then we can say x is greater than y. Okay. So, by that way, root a minus root b whole square not equals to 0, then root a minus root b not equals to 0, imply root a minus root b whole square by 2 is greater than 0, because there is a whole square of root a minus root b. That is why this thing will give positive quantity. So, from this we can say arithmetic mean minus geometric mean is greater than 0. It will be the better way. So, when a not equals to b, then root a minus root b not equals to 0. This imply root a minus root b whole square by 2 is greater than 0. And from this we can say arithmetic mean minus geometric mean is greater than 0. So, this imply arithmetic mean is greater than geometric mean. So, we can conclude that arithmetic mean is greater than equals to geometric mean for two numbers when now where equality occurs when the numbers are equal, that is A equals to B. Okay, so for two numbers we can specifically mention that arithmetic mean is greater than equals to geometric mean, and equality occurs, that means arithmetic mean will be equals to geometric mean only when the two numbers are equal, that is A equals to B. Okay, so this is the way by which we can find a relationship between the arithmetic mean and geometric mean of two numbers. So arithmetic mean is greater than equals to geometric mean for, we can say, for two numbers. Say they are A and B. Okay. Here we choose a problem. So this problem will help us to find the relation, help us to understand the relationship between arithmetic mean and geometric mean properly. Okay. So here the ratio of arithmetic mean and geometric mean of two numbers A and B is m is to n. It is given that the ratio of arithmetic mean and geometric mean of two numbers A and B is m is to n. We have to prove that the ratio of these two numbers, that is A is to B, equals to m plus root over of m square minus n square is to m minus root over of m square minus n square. Okay. So let us study how we can prove this. Solution. The arithmetic mean of two numbers A and B is A plus B whole divided by 2, and the geometric mean of that two numbers is root over of AB. We choose the positive geometric mean, because we know geometric mean of two numbers A and B is plus minus root over of AB, and from that plus minus root over of AB we choose only the positive mean, that is square root of AB. By the problem, arithmetic mean is to geometric mean equals to m is to n. This implies A plus B whole divided by 2 is to root over of AB equals to m is to n. This implies A plus B whole divided by 2 into 1 by root over of AB equals to m by n. Ratio when converted into multiplication, that means this is to this, also can be represented as this into 1 by, that means reciprocal of this. That is why we can write a plus b into 1 by root over of ab. This imply a plus b by 2 root over of ab equals to m by n. Now this is like a by b equals to c by d. Already we know in our previous classes we learned about the formulas of ratio and proportion, and from that formulas one of the important formula is componendo dividendo. So now we have to apply componendo dividendo here. If P by Q equals to R by S, then by componendo dividendo we can write P plus Q by P minus Q equals to R plus S by R minus S. Okay, so this is one of the special ratio proportion formula. We can say formula, that is componendo dividendo. With the help of this componendo dividendo, we can write a plus b plus 2 into root over of ab whole divided by a plus b minus 2 into root over of ab equals to m plus n whole divided by m minus n. Okay, so here a plus b is like p, 2 into root over of ab is like q, m is like r, and n is like s. Okay, we can also represent a as root over of a square, b as root over of b square, and plus 2 into root over of ab as 2 into root a into root b. Similarly, this as root a whole square plus root b whole square minus 2 into root a into root b equals to m plus n by m minus n. So this will give root a plus root b whole square by root a minus root b whole square by following the identities of x plus y whole square and x minus y whole square. So this is equals to m plus n by m minus n. So we can also write this as in terms of whole square. A root a plus root b whole divided by root a minus root b whole square is equals to m plus n whole divided by m minus n. Then removing the square from left hand side, we can write root a plus root b whole divided by root a minus root b equals to root over of m plus n by m minus n. Here we choose positive square root. So we can write this as root a plus root b whole divided by root a minus root b equals to root over of m plus n by root over of m minus n. Now this is like p by q equals to r by s. We can also apply componendo dividendo here. So root a plus root b plus root a minus root b whole divided by root a plus root b minus root a minus root b equals to root over of m plus n plus root over of m minus n whole divided by root over of m plus n minus root over of m minus n. Okay, by following this componendo dividendo. From this we can write this by following componendo dividendo. Now if we remove brackets, then we have root a plus root b plus root a minus root b whole divided by root a plus root b minus root a plus root b equals to root over of m plus n plus root over of m minus n whole divided by m plus n minus root over of m minus n. Cancelling root b from numerator and root a from denominator, we get root a plus root a, that is twice of root a by twice of root b equals to root over of m plus n plus root over of m minus n whole divided by root over of m plus n minus root over of m minus n. We can cancel this 2 from numerator and denominator. Now to find a by b, we have to do square on this thing, and to balance this we have to do square on both sides. That is why a by b is equals to m root over of m plus n plus root over of m minus n by root over of m plus n minus root over of m minus n whole square. Squaring both sides. So when we square on this thing, that is root a by root b whole square, will give a by b, and then square of this thing will give this root over of m plus n plus root over of m minus n whole divided by root over of m plus n minus root over of m minus n whole square. So we get, this implies a by b is equals to root over of m plus n plus root over of m minus n whole square by root over of m plus n minus root over of m minus n whole square. We can break this whole square as root over of m plus n plus root over of m minus n whole square whole divided by root over of m plus n minus root over of m minus n whole square. So this implies a by b is equals to, now this is like a plus b whole square. A square plus b square plus 2 into a into b. This is like a minus b whole square. A square plus b square minus 2 into a into b. This implies a by b is equals to root over of m plus 1 whole square will give m plus n. Root over of m minus n whole square will give m minus n. plus 2 into root over of m plus n into root over of m minus n can be written as root over of m plus n into m minus n. Okay. So we can represent this as 2 into root over of m plus n into m minus n. Root over of m plus n whole square means m plus n plus root over of m minus n whole square means m minus n minus 2 into root over of m plus n into m minus n. We can cancel plus n minus n from numerator and denominator also. So this will give a by b is equals to 2m plus 2 into root over of, this is like a plus b into a minus b. This will give a square minus b square, that is m square minus n square, and in the denominator m plus n, 2m plus 2m minus 2 into root over of m square minus n square. By following the formula a plus b into a minus b equals to a square minus b square, we can write m plus n into m minus n as m square minus n square. This implies a by b is equals to, we can take 2 as the common factor from numerator, and after taking 2 common we have 2 into m plus root over of m square minus n square, and from the denominator when we take 2 as the common factor, then the rest of the term will be m minus root over of m square minus n square. Cancelling these two, we get a is to b equals to m plus root over of m square minus n square is to m minus root over of m square minus n square. So this is the way by which we can prove that when the geometric mean, when the arithmetic mean and geometric mean of two numbers are in a relationship. That means in this problem, the arithmetic mean and geometric mean of two numbers a and b are in a ratio which is equals to m is to n, and from this we have to prove the ratio of these two numbers, that is a is to b equals to this, and this is the way.